Good day, students! Welcome back to our channel. Today is another fun and exciting day of learning and discovering new things. And today's discussion is all about projectile motion. Are you ready? Let the learning begin. Projectile is any body or object that is given an initial velocity, then follows a curved path determined by the effect of gravitational acceleration. The path followed by a projectile is called a trajectory. A body in projectile motion is said to have established a parabolic trajectory with a horizontal and a vertical component. Thus, a projectile motion is a combination of a horizontal motion with a constant velocity and a vertical motion with a constant acceleration. Are you familiar with the game volleyball? Let's take it as an example. The vertical velocity of the volleyball being served decreases as it rises to the air due to the opposing direction of gravity towards the motion. When the volleyball reaches the maximum height, it momentarily stops, causing the vertical velocity to be zero. When it reaches the ground, the vertical velocity increases since the direction of the volleyball's motion is the same with the direction of gravity. Some things may seem boring, but a little curiosity will lead you to its sense and importance. Projectile motion is not a usual topic in a casual conversation, but this concept also applies in our everyday life. We are not just aware of it. For instance, in our example a while ago, in playing volleyball, proper positioning and proper angle will help you achieve the target or the goal. So if you want a service ace, you must learn how to position yourself and angle yourself properly. Did you know that at an angle of 45 degrees, you will have the longest horizontal range? And as the angle increases, the vertical range also increases. Physics may seem complicated, but it will actually help you understand life better. Here are the variables involved in projectile. For the horizontal component and for the vertical component. Next are the equations used in solving projectile. Let us have a sample problem. Sample problem number 1. A projectile is thrown with a speed of 100 feet per second in a direction 30 degrees above the horizontal. Solve for letter A, the height to which it rises, letter B, the time of flight, and lastly letter C, the horizontal range. For our given initial velocity 100 feet per second, use 100 cosine 30 for horizontal component and 100 sine 30 for vertical component. Our angle theta is equal to 30 degrees. For our unknown, age or height, the time of flight, and R or horizontal range. For the formula, use age is equals to VI squared sine squared theta all over 2G. For time of flight, use VIY all over G times 2. And for the horizontal range, use R is equals to VIX times T. For the solution, substitute the given to the formula. Age is equals to 100 times sine 30 squared all over 2 times 32.2, and age is equal to 38.82 feet. For the time of flight, substitute the given. We have 100 times sine 30 all over 32.2 times 2. The answer is 3.11 seconds. For the horizontal range, substitute the values. We have 100 times cosine 30 times 3.11 is equals to 269.33 feet. For our answers, the height to which it rises is equals to 38.82 feet, the time of flight is equals to 3.11 seconds, and the horizontal range is equals to 269.33 feet. A man drives horizontally off a cliff at 20 meters per second. He lands 40 meters from the base of the cliff. How high is the cliff? And if your answer is 19.62 meters, you got it right. Now, the next problem is for you. Try to solve it, and if you feel a little unsure, just take a look back in our discussion. Happy solving! And that's all for today. Again, we are the Motionarists from BSCE 2H. Thank you for watching. Bye-bye!